Welcome viewers. In this video we'll see the problem based on the framing the Hamming code. The Hamming code is used to detect as well as correct the error, right? In this we'll see the problem. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic Hamming code. The explanation of Hamming code also available in separate video. Link is available in the description box. Determine the single error correcting code for the information code 10111 for odd parity, right? So this is the information bit 10111. We are using the odd parity. We need to frame the Hamming code for this information bit 10111. The first step is we need to find number of parity bits required. Hamming code means the parity bits are located at a particular location. In that, first we need to see how many parity bits are required, right? The formula is available, the condition is available, 2 to the power p greater than or equal to x plus p plus 1. We need to determine the p value such that it will satisfy this condition. The p is nothing but number of parity bits, x is nothing but number of digit in the information bit. So here 5 digits are available, so x equal to 5. Right, p equal to parity bit. First we will take p equal to 3. So substitute the value 2 to the power p, 2 to the power 3 greater than or equal to x is nothing but 5, information bit, the 5 digits are available. The p we assume that we assign that p equal to 3 plus 1. So 2 to the power 3 is 8 greater than or equal to 5 plus 3 plus 1 is nothing but 9. So 8 greater than or equal to 9. So this condition is not satisfied. So the number of parity bit is not 3 because this condition is not satisfied. So that will go to p equal to 4. We will take the p equal to 4. Again substitute the value 2 to the power p greater than or equal to x plus p plus 1. So now the p value is 4. 2 to the power 4 greater than or equal to x is 5, p equal to 4 plus 1. 2 to the power 4 is 16 greater than or equal to 5 plus 4 plus 1. 5 plus 4 plus 1 is 10. So 16 greater than or equal to 10. So this condition is satisfied. So we can take number of parity bit as 4, right? So the number of information bit is 5, number of parity bit is 4. So totally we have 4 plus 5, 9. The Hamming code, we are going to frame the Hamming code in that the total code is code bit is x plus p equal to 5 plus 4, that is equal to 9. We are going to generate the 9-bit Hamming code. Now we'll see the location where we need to locate this Hamming this information bit and as well as the parity bit, right? So this is the bit designation. There are 9 bits available. So p1, p2, d3, p4, d5, d6, d7, p8, d9. How this is assigned, how we are mixing this parity bit and information bit. P refers parity bit, D refers information bit. This parity bit is located 2 to the power 0, that is position 1, 2 to the power 1, position 2, 2 to the power 2, position 4, 2 to the power 3, position 8, like that it will go. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, like that it will go. That is 1, 2, 4, 8, 16, 32, like that it will go. The explanation available in separate video, right? So based on that, the P1 is located at 1, P2 located at 2nd, P4, then P8, right? So the remainings are automatically the information bit, D3, D5, D6, D7 and D9, right? Now we combine the parity bit as well as information bit. The totally there are 9 bits are available. The location number, this is a location, bit location 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we need to write the location number, the binary digits. This is the decimal, right? For 0 means 0001. For 2, 01, 0010. For 3, 0011. For 4, 0100. For 5, 0101. For 6, 0110. For 7, 0111. For 8, 1000. 9, 1001, right? So this is a bit designation, bit location. The corresponding binary numbers are given here. right? So the information is already available, 10111, 10111. So the information 10111 located at D9, it is located at D9, D7, D6, D5 and D3. So the 5-bit information is located in the corresponding position. Now we need to identify P1, P2 value, P4 and P8 value, right? So by combining all, you can frame the Hamming code. So first we will see how to find the P1 value. So the P1 value, the binary location number is 0001. The 1 is available in the LSB, last digit is 1. So wherever 1 is available, that location will be verified by P1. So where is 1 is available? Says this 1 is available in this LSB, is available in D3, D5, D7 and D9, right? So the 1 LSB, the LSB 1 is available at D3, D5, D7 and D9, D8 not available, sorry, this P8 is not available, here also D6 also not available. So available in 3, 5, 7 and 9. So the 3 value is 1, 5 value also 1, 7 value is 0, 9 value is 1. So totally 3 ones are available. The 3 means odd number. So the given parity also odd. So number of ones are odd. The odd parity given means the P1 value will be 0, right? So the P1 will verify 3, 5, 7 and 9. In 3, 5, 7, 9, there are 3 ones are available. In 3, 1 is available, 5 is 1 is available, in 7, 0 is available, 9, 1 is available. 3 ones are available. 3 means odd number. The parity bit, parity given also odd, so that 0. Now we'll go to the P2. See the P2 value is 0010. The second bit, from LSB, the second bit is 1. Wherever 1 available in the second position, that location will be verified by P2. Now we'll see this. So in the 3, 1 is available. Second bit 3, 1 is available. Right? Here not available. Here available. In 6 available. In 7 also available. Right? This is available in 3, 6 and 7. Right? The 9 not available. In 5 also not available. Right? So it is available in 3, 6 and 7. The 3 value is 1. 6 value is 1. 7 value is 0. So the 2 ones are available. In 3, 6, 7, the 0 available, here 2 ones are available, even number. But the parity given as odd parity. So even number of ones available, but the odd parity is given. So the P2 value will be 1. Here we have even odd parity, odd number of ones. So this is 0. Here odd parity but even number of ones is there. So this location will be 1. Now we'll go to P4. P4 from MSB, the second position is 1. From MSB second position. Wherever 1 available in the second position from LSB, that will be verified by P4. We'll see that. So in D5 it is available in the second position. The D6 also available. D7 also available. In D9 not available. So 5, 6, 7. In these 3 positions, the second bit is available 1 from LSB. So it will verify position 5, 6 and 7. So 5, 6, 7 having 2 ones are available. 2 means even number, but the given parity is odd. So that P4 also 1. The P4 value also 1, right? Odd parity is given, but even number of ones are available. So the P4 value will be 1. Now we'll go to P8. P8. In P8 MSB is 1. The MSB value is 1. So wherever MSB value 1, it will verify. Only in D9 the MSB value is 1. So this P8 will verify the position 9. The 9, 1 is available. 1 means odd number. Right? Parity bit given also odd parity. Odd parity, odd number of ones. So that it is 0. Right? So P1 and P8, odd number of ones are available. So it is 0. P2 and P4, even number of ones available. So it is 1. So by combining this all, we'll have the Hamming code 1 0 0 1 1 1 1 1 0. This is nothing but the Hamming code, right? We'll see the description. What we discussed, the description is available. So the final 9-bit Hamming code is 1001 1111 right. So we'll see what we discussed. The description is available. P1 bit location 3 5 7 and 9. So this P1 will verify 3 5 7 and 9. In 3 5 7 9 there are 3 ones are available. 3 means odd number, the odd parity is given, so 3 is odd number, odd parity is given, so automatically 0. The P2 will verify bit location 3 6 and 7. In 3 6 7 the 2 ones are available. 2 means even number, but odd parity is given, so that the value is 1. Even number, odd parity means 1. Even odd parity, odd number means 0. Similarly, P4 will verify 5, 6 and 7. In 5, 6, 7 there are 2 ones are available. 2 means even number, but given as odd parity. Even number, odd parity means 1. Similarly, P8 is verifying 8 and 9. Right? 8 is the location itself and 9. In 9 we have only 1 is available. 1 means odd number. The parity also odd. So odd number, odd parity means 0. Right. So that P1 is 0, P2 is 1, P4 is 1 and P8 is 1. So that from that we can frame the final Hamming code. So you can see this location. 1 verify 3 5 7 9, 2 verify 3 6 7, 4 verify 5 6 7, 8 verify 8 and 9. The explanation available in separate video also. Right. So in this problem we framed the Hamming code for a given information. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.